Here by SAT math problem, okay, let's go to the question. Point C is the center of the circle shown below. Points D and F both lie on the circle as shown. The perimeter of triangle CDF is 60 units. What is the area of shaded region? Round your answer to the nearest hundredth. Okay, in the given figure, we have to get the area of the shaded region over here. To get the area of the shaded region, first we have to get the area of the sector. From the area of the sector, we have to subtract the area of the triangle CDF. Okay, first let's get the area of the triangle CDF over here. Now let me consider the two sides of the triangle CD and CF. Both of them are radius to the circle, so they are equal in length. Now let's consider the two interior angles of the triangle over here. These two interior angles are opposite to the sides of equal length. In a triangle, if two interior angles are opposite to the sides of equal length, then they must be equal in measure. Okay, for example, if I assume x as a measure of this interior angle, then the measure of this interior angle is also x. Okay, now let me add the three interior angles of the triangle CDF, that is x, positive 60 degrees. We know that in any triangle, the three interior angles will add up to 180 degrees. Okay, we have 2x positive 60 degrees on the left side. On the right side, we have 180 degrees. Now let's subtract 60 degrees from both sides. We get 2x equals to 120 degrees. Let's divide both sides of the equation by 2. Then we get x equals to 60 degrees. Okay, here I got the value of this x, that is 60 degrees. Okay, now let me replace x by 60 degrees over here and here. Okay, now in this triangle CDF, all the three interior angles are equal in measure. Then it is an equilateral triangle, and for this equilateral triangle CDF, we have the perimeter, that is 60 units. Now to get the length of each side of this equilateral triangle, we have to divide the perimeter 60 by 3. When I divide by 60 by 3, I am getting 20. That is the length of each side of this equilateral triangle is 20 units. Let me write over here, and here we have 20. Okay, now we know the length of each side of this equilateral triangle, and there is a formula to get area of an equilateral triangle. Okay, now let me write the stuff over here. That is area of equilateral triangle CDF equals to, the formula is square root of 3 over 4 times a square. Okay, here this lowercase a represents the length of each side of the triangle. We know that the length of each side of the triangle, that is 20. Let's plug in this 20 for a over here. Then we get square root of 3 over 4 times 20 square. Square root of 3 over 4 times 20 square can be written as 20 times 20. Here 4 goes into 4 one times, and 4 goes into 25 times. And here 5 times 20 is 100. 100 times square root of 3 is 100 square root of 3 square units. Okay, here I got the area of the triangle CDF. Now let's get the area of the sector over here. And there is a formula to get area of a sector. Let me write the stuff over here. Area of sector equals to, the formula is theta divided by 360 degrees times the area of the circle, that is pi r square. Okay, here theta is the central angle of the sector. The central angle of the sector is 60 degrees. Let me plug in 60 degrees for theta over here, divided by 360 degrees times pi times r represents the radius, and the radius of the circle is 20. Let me plug in 20 for r over here. Here 60 goes into 61 times, and 60 goes into 366 times. We get 1 over 6 times pi times, and this 20 square can be written as 20 times 20. Okay, here 2 goes into 6 3 times, and 2 goes into 20 10 times. Okay, here 1 times pi is pi, pi times 10 is 10 pi. 10 pi times 20 is 200 pi divided by 3. Okay, here I got the area of the sector as well. Now let's get the area of the shaded region. Okay, let me write the stuff over here. Area of shaded region equals to, let me write it over here. As I said already, we have to subtract the area of triangle CDF from the area of the sector, that is 200 pi over 3 negative 100 times square root of 3. Okay, now let's evaluate the value of this expression using Desmos. Okay, let me give this expression as input, that is 200 times pi divided by 3 negative 100 times square root of 3. Okay, here I got the value of the expression, that is 36.2344. It keeps going. According to the instruction, we have to round this value to the nearest hundredth. When I round this value to the nearest hundredth, I am getting 36.23. Therefore, the area of the shaded region is about 36.23 square units.